So, we will next look into a topic that includes some more combinational logic elements, decoders, multiplexers and PLAs. So, these are slightly higher level than the gates, logic gates that we have considered so far. So, they are essentially made up of logic gates only, but for so they will have a good number of logic gates in them. So, for our understanding, so for many a time we will find that the function that we want to realize is similar to one of these components, decoder, multiplexer and PLA. So, as a result, so there are many integrated circuit chips that have been developed for that realizes these functions in them. So, we can use those chips directly. Okay. So, we do not have to do in terms of basic logic gates. So, that way the design process becomes simpler. Okay. So, we will be looking into this one by one. So, first we will look into decoders. So, a decoder, it is a logic circuit that accepts a set of inputs that represents a binary number and activates only one of the output that corresponds to the input number. So, what we mean is that it has got, so if this is the box corresponding to decoder, this is the logical block that realizes the decoder, then it accepts some input. Okay. So, suppose it accepts 2 input, and so this 2 bit 2 input that I have, say I input 0 and input 1. Now, they correspond to some binary number, like say if these 2 bits are 0 0, that means it is representing the number 0. If this is 0 1, it is representing the number 1, 1 0 is 2 and 1 1 is 3. Accordingly, this in the output side I will have 4 lines. Okay, I will have 4 lines, and out of these 4 lines, so if I give say pattern 0 0, then this line output will be high, or and others will be 0. Okay. So, if I write in terms of say O0, O1, O2 and O3. So, depending upon the binary pattern that I am feeding, so one of the 4 outputs will be active and others will be inactive. So, active means it may be high where others are low, or it may be the reverse way, that active means the output is low and while rest of the outputs are high. So, either way it can be done. So, a decoder circuitry looks at its inputs, determines which binary number is present there, and activates the one output that corresponds to the number. All other outputs they remain inactive. Now, you can very easily design some circuit using some basic logic gates, and in fact, it is done that way only, but if your circuit is very function that you want to realize is quite complex, then it may be that a good number of gates. So, we are replacing by a decoder to make the design simple to understand. Okay. So, in a general form, a decoder has got n input lines to handle n bits and form 1 to 2 power n output lines to indicate the presence of one or more n bit combinations. So, this is the basic decoder. So, we say it is 1 to 2 to the power n to 2 to the power n decoder. So, that way it is taking n input lines, and depending upon the value of n, one of the 2 power n outputs will be made active. So, you can see that this basic AND gate, so that acts as a decoding element because it produces high when all its inputs are high. So, if I take one AND gate, you see the AND gate. So, this output, it has got one output and 2 inputs. So, this is also in some sense decoder, because for when the input pattern is 1 1, then only it is giving 1, all the other cases it is giving 0. So, output is deactive. So, since it has got only one output and that one output is high when 1 1 is high. On the other hand, if you say OR gate, so OR gate in that sense it is not a decoder, because it produces 1 for 3 different combinations. So, 0 1, 1 0 and 1 1, for all the 3 combinations. So, it is producing 1. So, by if I just look at this output and see that this is 1, I do not know, I cannot tell what was the corresponding input pattern. But for AND gate, it is true that as soon as you look into the output and is find a 1 there, you know the input pattern is 1 1. So, yeah, AND gate in some sense can be said to be a decoder. Of course, you can tell that for OR gate also, if I get a 0 at the output, if I get a 0 at the output, I definitely know that the input patterns are 0 0. So, if I am looking for an active low decoder circuit, okay, that is it lowers the output when the corresponding input pattern is applied. In that situation, OR gate will act as a decoder, whereas AND gate will not act as a decoder. So, that is a very rudimentary type of decoder that we are talking about. Now, so this is the decoding logic for the binary code 1001 with an active high input. So, so if you get if I have to design a black box or some logic circuit such that for 1001 it will give the high output. So, I can do it like this. So, I can design a circuit where all these things is put inside the box, and this box takes 4-bit input, and so only when this 4-bit input is 1001 as per the design of this circuit, you see that the output is 1. Similarly, if you are talking in terms of this value, so A0, A1, A2, A3. So, here I am getting A1 bar, here I am getting A2 bar. So, they are ANDed. So, you get A3, A2 bar, A1 bar, A0. So, when this particular input combination comes at the block input, then only this output will be made active. So, this way we can realize circuits, okay, to get the decoders. In a general form, so we have got this A0 to AN minus 1. So, n inputs are given to a decoder and there are m outputs O0 to OM minus 1. Now, this n inputs, so they can correspond, they can give values which may be any one of these 2 power n input code set. Okay. So, this is 2 power n input codes are coming, and then it is producing output which is one of these m outputs will be made high. So, O0 to OM minus 1, one of the outputs will be made high. So, there are 2 power n possible input combinations from A0 to AN minus 1, and for each of these input combinations only one of the m outputs will be active high, all others will be low, all others will be low. So, they will be, so if high is 1 and low is 0, so you can say it is 1 and 0. So, this is the basic decoder definition. Okay. So, we represent it by a square like this. As I said that there can be 2 variants of the decoder. One decoder is active low output, where the whichever output is active, so that output will be 0 and the rest will be 1, and other category is active high output, where I have got this decoder who the active output will be 1 and the rest will be 0. And there are IC chips that have been designed for both the categories, like 74138 is an IC chip which has got, which is a decoder function with active low output, and 74139 is again a decoder, but it has got active high output. So, this in case of active low output type of decoder, the entire decoder can be implemented with NAND gates and inverters, whereas this active high output, the decoder can be realized using AND gates and inverters. So, as we have seen previously, like in this diagram. So, here I was looking for active high output. So, I could do that using inverters and AND gate. So, if I was looking for active low output, then I have to use inverters and NAND gates. So, the first one we will be considering is a 2 to 4 line decoder with enable input. So, what is there? So, here this is the 2 input A and B that are the that gives us to the output number that should be made active. Okay. So, this is active low. So, corresponding to A and B, whichever output is getting selected, that output will be low and the rest of the outputs will be high. So, for example, when AB is 0 0, then D0 is 0 and rest of the D1, D2, D3 they are 1. Similarly, for 0 1, D1 is 0 and the rest of the outputs are 1, like that. And there is one additional input called enable or E, and this the outputs will be coming properly only when this E is equal to 0. If E is equal to 1, then all these D0, D1, D2, D3, so they will be giving the value 1. So, none of the outputs are active, okay, because we have taken 1 as active, is 1 is the non-active state and 0 is the active state. So, if this E is equal to 1, then all the outputs are 1. So, the all of them are non-active node, in non-active mode. So, this way we can augment the decoder to have an enable input as well. So, next we will look into, so this the circuit operates with complemented outputs and a complement enable input, as we have said. So, output active output is 0 and decoder gets enabled when E is equal to 0. Only one of the output can be equal to 0 at any given time, all other outputs are equal to 1. Output whose value is equal to 0 represents a min term selected by inputs A and B. So, A and B they will it can select 4 min terms with the 2 input function. So, it has got 4 min terms, and in this so this D0, D1, D2, D3 they are actually corresponding to min term 0, 1, 2 and 3. So, based on this AB value, the corresponding min term is getting selected and corresponding D bit is made equal to 0, and circuit is disabled when E is equal to 1. For getting the proper operation of the circuit, E should be set to 0. We look into another example. So, it is a 3 to 8 line decoder. So, 3 bit input. So, if the n equal to 3. So, naturally I can have 2 power n, that is 8 as the m value or the number of outputs that it can have. Now, here you see that what we need is for O0, okay, O0 output will be equal to 1 when all these A, B, C bits are 0. So, how have we represented it? So, this is an AND gate here, and you see the inputs are coming from A bar, then this is coming from this B bar. Okay. So, this is the line B bar. So, inverted B. So, this is the B bar and also C bar. When A bar, B bar, C bar, so these two values are equal to 1, then this output O0 will be equal to 1 and all other outputs will be equal to 0. So, this is the truth table that we have. So, when this ABC is 0 0 0, O0 is getting selected, O0 is becoming equal to 1 and rest of the outputs are 0. So, for any other combination, one of these outputs will be made equal to 1. So, this way we can have 3 to 8 line decoder. This decoder can be referred to in several ways. First of all, it can be called a 3 line to 8 line decoder, as there are 3 input lines and 8 output lines. So, it is called 3 line to 8 line decoder. Now, see this 3 and 8, so this information they are redundant, like as soon as I say that 3 are the input lines, so 8 are the output lines. Similarly, if I say 8 as the output line, then 3 is the input line. So, it can also be called a binary to octal decoder, okay, or converter, because it takes a 3 bit binary input code and activates the one of the 8 outputs corresponding to that code. It is sometimes called it is also sometimes called 1 of 8 decoder. So, these are various terminologies that we have: 3 line to 8 line decoder, 1 of 8 decoder. So, 1 of 8 decoder means that out of 8 only one of them will be made active. So, it is called 1 of 8 decoder. So, naturally, since output there are 8 outputs, so we must have the input as 3 bit, okay, the 3 input lines should be there. So, this way there are various names for the circuit. So, next we look into the logic diagram of this integrated circuit chip 74138. So, this 74138 is a 3 bit decoder. So, we have got A0, A1, A2 as the input, and it is when this so it has got a number of enable lines. So, this E1, E2 and E3, there are 3 enable lines. Out of that, the circuit is active when E1 bar is E1 equal to 0, that is E1 bar equal to 1, E2 equal to 0, that is E2 bar equal to 1, and E3 equal to 1. In that case, this AND gate output will be 1, and only when this AND gate output is 1, so these NAND gates are there and their output can be made equal to the proper value. If this AND gate output is 0, then this all the outputs are tied to 1. Okay. So, all these 8 outputs are tied to 1. So, for getting the operation from this circuit, I should set E1 equal to 0, E2 equal to 0 and E3 equal to 1, then only this will happen. So, apparently it seems, why do we need so many enable lines? So, E0, E1, E2 and E3. So, this helps in the logic design many times. So, maybe in my circuit I have got several decoders and the same input combination is going to a number of decoders, and but I do not want them to be active simultaneously. So, this availability of this multiple enable lines, so it helps in the process. Okay. So, that is why the 74138 has got a structure like this. So, this is the truth table for 74138. So, this is when this E3 is so whenever this E2 is high, so E2 bar becomes low. So, this your decoder is disabled. So, all the outputs are high, or if E1 is high, whatever be the value of E3 and E2, then also all the outputs are high, and if E3 is low, whatever be the value of E1 and E2, so again all the values are all the outputs are high. So, there is no priority between E1, E2, E3. So, say for correct operation of the circuit, E3 should be high, E1 should be low and E2 should be low. Once I have put these values, so rest of the bits A0, A1, A2, if it is if the all of them are low, then O0 bar will be low and rest will be high. Similarly, if this is if I put this A1 and A2 as 0 and A0 as 1, so this will be putting O1 bar to be O1 line to low and rest of the lines to high. So, this is the 74138 3 to 8 bit decoder, which is an active low 1 of 8 decoder. So, there is an enable function on this device, a low level on each of the E1 dash, E2 dash and E2 dash, and a high level on input E3 is required to make the enable gate output high, and the enable is connected to an input of each NAND gate in the decoder. So, it must be high for the NAND gate to be enabled. If the enable gate is not activated, then all the 8 decoder outputs will be high regardless of the states of the 3 input variables A0, A1, A2. So, that is for the enable part. Next, we will look into how can I make a 5 to 32 bit decoder using this 3 to 8 decoders. Okay. So, so I want to make a hierarchical structure. So, in my application I need a 5 to 32 decoder, whereas in my library I do not have these 5 to 32 decoders available as a chip. What I have are only 3 to 8 decoders 74138. So, what we can do? So, since there are 32 outputs, so I will need 4 such 74138 chips. So, these are the 4 such 74138 chips. Now, since there are 5 input lines, so this A0 to A4, so these are the input lines that I have. Now, this A0, A1, A2, so they are fed to A0, A1, A2 of all the 3 all the 4 decoders, all the 4 74138s. Now, using this A3 and A4, we select between the 74138 that we want. For example, the first 74138 chip that I have put, so that controls the outputs O0 to O7. Second 74138 controls the outputs O8 to O15. So, third one O16 to O23 and the fourth one O24 to O31. Now, what is required is if all these A0, A1, A2, A3, A4 are 0, in that case only this O0 bar should be low and all these outputs till O31 bar they should be high. Now, how to do that? So, this A0, A1, A2 is fed here. So, this enable line, so we connect A3, A4 and this the other the E3 line. So, E3 line will tie to high and this E1 and E2. So, we connect this A3 and A4. So, when this enable E is active when A3 equal to 0, A4 equal to 0 and this is already 1. So, this decoder will be active when A3 equal to 0 and A4 equal to 0. For the second decoder, what we have done? We have connected the line A3 to E3 and then and A4 to E2 and the E1 line we have grounded. So, this is E1 is always there, but if I give A4 equal to 0 and A3 equal to 1, okay, if I give A3 equal to 1 and A4 equal to 0, then this decoder will get selected. So, this enable will be active and all the other enables will be deactive. So, as a result all other outputs will be high, but depending upon the value of A0, A1, A2, one of the outputs from this set will be low. So, you see that I do not need any extra gate, only thing is that we can just apply this E3, E1, E2 properly. Okay. Yes, so E3, E2, E1 properly, so that these decoders will be this 4 to 8 decoders, they can be used to construct 5 to 32 decoder. So, that is why we have got this multiple number of enable lines. A simpler example, how to construct a 4 line to 16 line decoder using 2 3 line to 8 line decoders. So, we have got 2 3 to 8 decoders and we use them to get a 4 to 16 line decoder. So, we assume that each of these decoders they have got one enable line, and for the decoder to operate this enable line should be equal to 1. Okay. So, this x, y, z, so these are the 3 inputs coming now, and there is another input w. So, w is the most significant bit and so and x is the least significant bit. So, this x, y, z line, so they are fed to both the decoders and this w line is fed to the enable of the lower decoder and this inverted w is fed to this upper decoder. So, this upper decoder is enabled when w equal to 0 and when w equal to 1 the lower decoder will be enabled. So, this I can say that for D0 to D7 the for 4 bit patterns that we have are say for say D5 in 4 bit. So, it is coded as 0 1 0 1. So, this x, y, z and w. So, this is x, this is y, this is z and this is w. Okay. So, this w is equal to 0, that means the lower decoder is disabled, only the upper decoder is enabled and the upper decoder in the line x, y, z is getting 1 0 1. As a result, the D5 output will be made high and all other outputs will be made low. And since this lower decoder is disabled by making E equal to 0, okay, so all the outputs will be low. So, ultimately if you look into this entire set of 16 outputs D0 to D15, only the D5 output will be high and all other outputs will be low. So, in this way you can use 3 to 8 decoders to make 4 to 16 decoder or even higher, like we have previously we have seen that 3 to 8 decoder used for getting 5 to 32 decoder. So, that way also can be done. Next we will be looking into how can I get 4 lines. So, this is the description of that 4 to 16 line decoder. So, when w equal to 0, top decoder is enabled and the other is disabled and the bottom decoder outputs are all zeros because the the enable input is 0 and the top 8 outputs generate min terms 0 0 0 0 to 0 1 1 1. So, that is corresponding to those min terms, the output the 8 outputs will be there, and when w equal to 1 the enable conditions are reversed, that is the upper decoder is now disabled and the bottom decoder is now enabled. So, it will realize the functions min terms 1 0 0 0 to 1 1 1 1 and upper decoder will be outputting all zeros. Now, these decoders they can be used for realizing combinational functions directly. For example, suppose we look into that adder function. Okay. So, in case of adder, you know that the sum is given by sigma 1 2 4 7. So, this x y z, so it is a full adder. So, if I have got full adder, so this is the truth table. So, x, y and z and sum and carry. So, this is so 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So, when this so this is coming this 0 0 1 0 1 0 0 1 1 0 0 1 1 0 and so this is 0 1 and this is 1 1. Now, for sum is 1 for this combination that is 1 2 4 and 7. For these cases sum is equal to 1 and the carry is equal to 1 for 3 5 6 and 7. So, this is that 3 then 5 6 and 7. For these cases carry is equal to 1. So, this is the min term based representation. So, if you are trying to realize some circuit using decoder, so first we have to come to the min term representation of the function, where it lists down the min terms corresponding to the function. Now, now we use a decoder. So, this is a 3 to 8 decoder. So, this x, y, z, so they are connected to the input side. Now, output sum will be equal to 1 if the combination 1, 2, 4 or 7 are chosen, such that is if this x, y, z value is such that this output 1, 3, 4 or 7. So, any of them will be equal to 1. In that case, sum output will be equal to 1, and we have got this carry output. So, this will be equal to 1 if this 3, 5, 6 and 7, any of these outputs are 1. So, this 3, 5, 6 and 7, so they are outputs are 1. So, from the min term, so we can figure out the lines that are important for the function and we OR them, okay, to get the corresponding function. So, this way we can realize any combinational function by means of decoders. So, the point is that you have to convert it into min term representation, and from the min term representation, so you have to go. It is not from the Carnot map, it is from the min term representation of the function. So, next we will be looking into encoders. So, encoders are just the reverse of decoder. So, in case of decoder, from less number of lines, so we are going to more number of lines. For the encoder, we will do just the reverse. We will start with the more number of lines and from there we will come to less number of lines. So, that is also useful in many cases, particularly when we are trying to reduce the amount of information that we need to send from one place to another. Okay. So, number of bits used for transmission and all. So, we use encoders so that we can send more amount of information using lesser number of bits. So, we will see that in successive class.